So we are starting out this evening with traffic light. Let me pull up this one here. So this is the website for Canadian STEM support, sponsored by Tom and friends. So today's webinar, if I go to the webinars, is the third, I believe. Tom, is that correct? The third one?
Yes, that's right.
Okay, so it's the third in a series of 6 weekly webinars. And tonight we're looking at doing traffic light with Python software. And you'll notice that the previously recorded webinars are available here in video format if you wanted to go back and review them or share them with a colleague. So under the Ontario Coding and STEM activities, we have tonight's activity, which is traffic light. And you can see here that we have a brief video of how the activity would go, a description of the activity, and there's a slide deck that will walk you through the steps that we're going to do tonight. So if you were teaching it to a group of students, this slide deck would be helpful in walking you through connecting the hub and all the different steps you would do to go through the activity that we're doing tonight, with some extra information in there about like RGB and stuff like that. That's all available to you on the website. And Tom has some teacher notes here as well. So kind of a Cole's notes version for a teacher to be going through. It's all the notes we've had in the notes of the slide on the Google Slides. So I'm going to invite you to download this TNS file. So visiting the website and clicking on this TNS file will give you the option to download the file. And it's the traffic light Python starter script, if you will. You click on download. And then you can load that up into your emulator software. All right, if I could get a quick thumbs up or in the chat saying okay when you're ready to go with that software so I don't lose anyone there. Okay, so Luke, I went to stemsupports.ca on the website. I'll bring you to the website again. Stemsupports.ca. There's the homepage to STEM supports. And on the right-hand side at the top right, I have my pages, my subpages. So under Ontario Coding and STEM Activities, if I scroll down to traffic light, and then in this activity, you'll see a great big icon that says TNF. That's the TI Inspire file. It's our starter file tonight. Great, thanks, Tony. All right, so.
And as far as doing the activity, Tony, I think you're the only one that, do you have an innovator hub, Tony?
No, I don't have that. I don't.
Okay.
No.
So we'll connect afterwards and I'll set you up with one, okay?
Okay, sure.
All right, so connecting the Innovator Hub is pretty straightforward. You have a mini ISB or USB. Mini USB connects to the data port B down here. And the USB-A just goes directly into your computer. And on the emulator software, we have
a quick note too. So you're using the long cable to connect to your computer. If you're programming the hub off of your calculator, then you just use the short cable, and the B end goes in the innovator and the A end goes in your calculator.
Right. Thanks, Tom. All right, so the first page on the TI file, 1.1, is the hub light features. So we're gonna all run this program in order to see kind of what the hub can do. Tom, I noticed in the chat that Luke was having some questions about where to find the TI file. Can you follow up with that? I'm not sure if that got resolved. So once you have this file up, I'm going to get you to press Control R on the emulator, and that'll run this program, and you can watch what it does on your innovator. And it should give you an indication on the screen as to what's taking place. So if you get the randomly generating 20 different colors and randomizing everything, and then at the very end, you'll hear it beep and say, ta-da. That just highlights some of the built-in features that the hub has. It has flashing lights, it has RGB lights, it's got a speaker that can make some noise as well. So those are some of the things we'll be playing with. Good, Derek got it working. Good, good. And if you have any questions, just stop me as we go. So the page 1.1 is the Python code that causes all of those lights to blink and noise to happen. If you scroll down in that, you can see the sound notes that are produced, some delays, all kinds of stuff happening in there. And you can go back and look through that as a starter, a stem to get started on some of your own advanced coding later on. So let's just get started with the basics. So if I switch to page 2.1, and I kind of left that, I unfortunately left that in there. Does yours have a blank line underneath, write your code below, or does it have a blank code? I'm hoping it has a blank line. Blank, it's too bad, okay. So what we're going to do is I'll walk you through the menus to get that blink code. So if you click on menu, and then number 8 is TI Hub. And number 2 is the hub's built-in devices. And number 1 is your light, number 2 is your light output. So click 2. And then number 3 is going to be your blink. Now you'll notice that it pre-populates for me the code, the blink code, and it highlights the word frequency. If I hit the tab key on the emulator, it will give you a prompt to let you know what it's expecting for each of those inputs in that function. So the light blink function, it takes 2 parameters. One is a frequency, one is time. And the frequency is measured from 0.1 to 20 hertz. And the time is measured from 0.1 to 100 seconds. So I'm going to get you to put some values in there and get your light to blink. I'll use 10 and 5. And then I'm going to Control R to run that code. So in the 10 and if the 10 and the 5 are input there, so 10 is your frequency and 5 is your time. What did it do on, well, you can tell me what it did on my Innovator Hub, or what it did on your Innovator Hub. What is the 10, what happens there? Is it blinking 10 times? Is it blinking 50 times? Is it blinking 5 times? What happened on your screen? You can add that in the chat there for us on your Innovator. I'll run it again for you, Derek. Okay. So what's happening on my screen is I'm getting 10, or on my innovator, I'm getting 10 flashes per second for 5 seconds. So it's the red light flashing. So it's 50 flashes in 5 seconds.
So if you put in 1, 5, try that one. So that should be 1 blink per second for 5 seconds, so 5 blinks, eh?
That's right. Yeah, the time is the overall time. All right. So if that's working well, then we'll move to page 2.3. Now 2.3, I've got a lights.py script. So this one, this one looks like it's got a bunch of sub-functions. So these are sub-programs or defined functions. I'm going to define red with a how long parameter. And what it's going to do is we're going to put some code in here to turn red on. So I'm going to get you to navigate your way down to the 6th line. It's the blank line between write your code to display the red light below and sleep for how long. Once you're there,
just to frame things for a second here, Chris. So we're starting to code a traffic light. Is that what we're doing?
Yes, that's right. Yeah, we're coding a traffic light, and the traffic light has a bunch of different colors: red, green, and yellow. So we're going to start with red. We're going to try to get the red light working. And this time, instead of using just the blinking light, the light, the one that was blinking on your innovator, we're going to be using the RGB light. And RGB stands for red, green, blue. So if you're on line 6, you're tabbed in 2 spaces because Python requires tabbing. So that would the tabbing would mean that all the code that's tabbed 2 spaces over falls under this red function. I'm going to go to menu, 8 for the innovator hub.
I think you're on the wrong line, Chris.
Am I?
Just go back. I think your cursor is on the wrong line. Okay.
Thanks.
So, and that's a good reminder for everyone. Do you see where Chris's cursor is right now? So you want to be at the start of a blank line. And Luke is a little lost right now, but that's okay, Luke. Just follow along with Chris. You have the PowerPoint and the files to play with afterwards.
Okay, so once I've navigated my way to this the 6th line, the blank line, I'm going to go to menu, number 8 for the TI hub, number 2 for the hub's built-in devices, then I'm going to go to my color output, number 1, and then number 1 is RGB. So this will give me the code, the Python code for producing a light on my innovator. The color code is color.rgb, and I've got red, green, and blue. Now, if you remember, when I hit the tab key, it will prompt me for the values it's looking for in each of those positions. So if I hit tab, you'll see it's looking for a 0 to 255 for each of those 3 inputs. So 0 is none of that color. Green, or 255 is all of that color. So I want you to produce a red light. How would you produce a red light? What numbers would you put in for red, green, and blue to produce a red light? Give it a try on your, or actually you wouldn't be able to give it a try yet. So yeah, Derek's got it. 255, 0, and 0 for those 3 values. So you'll replace the red with 255, the green with 0, and the blue with 0. Once you have that, I'm going to get you to press on your calculator Control B, as in Bob. Control B, and you'll see at the top of the file it says saved successfully. If we don't press Control B, you will run the red, you can call the red command, but it won't do anything because right now red isn't stored with anything. So I've stored this command with the proper parameters and saved it. And now when I go back to page 2.1, you go back to 2.1 with me, we can erase our blink code. Or if you just want to go on the line below it, if you don't have a very long blink, erase your blink code. And now I can just type the word red, open a bracket. And if you remember, the parameter for red was how long. So I'll just put red on for 4 seconds. So I'll type red, open bracket 4, close that bracket. Now try running that code, Control R. Okay, your shell should say that you're turning the red light on for 4 seconds, and then it's turning the light off. Thanks, Derek. Okay. So I'm going to go back to page 2.3, where I've listed my subfunctions for the various colors. I'm going to scroll down to the green function, make my way to line 12, where that blank space is, move myself over to the right tab space, 2 spaces in, and I'm going to give you an opportunity to try on your own to get the green code in place. I'm going to turn my emulator off and just show you the hub. I'm going to put my code in while you're putting yours in.
Paul had a question. He says, red stayed on. Is it supposed to do that?
Paul, did you start with the starter code that we sent out, or did you start with coding it from scratch? Oh, no, it's not.
I wonder if, Paul, did you delete the off command that came after Chris's thing? So did you just run red? And was there a line of code underneath that said off still?
Oh, okay. Yeah, you're right. Sorry. Yeah, I missed that. Thank you.
Okay, so without revealing the answer, I'm going to switch over to page 2.1. And now I'm going to add a new line below red 4. I'm going to type green 4 because I just saved the code for green in my other slide. Now, you know what I forgot to do is I forgot to Control B to save the changes that I made. If I don't Control B, those changes won't happen. Let's try that again. Okay, now I'm going to Control R to run it. I should get a red light for 4 seconds, and then a green light for 4 seconds.
Tony had a question. What does sleep do?
So sleep, Python will run in parallel. So once you kick off a red light, and then like if you kick off a red light and say it's for 4, well, let me pull up the code here. If I do color RGB 25500, that's turning on the red light. Immediately, it will call the next function that's listed in 2.1. It'll turn the green light on right away, unless I sleep or wait for that long before continuing out of that function. All right, so I've got red and green. And you can see what I've done for green is color.rgb 02550. The next one is yellow.
I got an error message though, Chris. Mine says green is undefined.
Green is undefined?
Yeah. Why would it do that? Oh, thank you, Derek. Okay, so Derek said something about Control B.
You didn't save your code. Yeah, Control B.
So do you guys see that how do you know if you haven't hit Control B? Has anyone noticed that? Yeah, Derek says there's a little star. You're right. In the name of the program, in the top, a little star shows up if it's not saved yet. As soon as you hit Control B and you save it, the star disappears.
All right, so I'm going to menu, 8 for hub, 2 for built-in devices again. I'm on the yellow one now. We're starting to put yellow in. 1 for color output, and 1 for RGB. And here, you're going to have to play around with the colors a little bit to figure out what a yellow is, because all of a sudden we don't have a yellow in these options. Now, in the interest of time, I think I'm just going to give you the code that works best for me. Paul, I like your background, by the way. Looks great. So the yellow light that works best for me, I find, is 255, 128, and 0. You can get some variant of that. And the kids, if you're working with students and you have more time, the students would have fun playing around with that, trying to get the right color for yellow. I'm going to Control B to save that and switch back to page 2.1 and run my yellow for 4 seconds. I'll run that one. I've got red for 4 seconds, green for 4 seconds, and yellow for 4 seconds. Now Tony's suggesting red and green on full. That will work. I found that when I do red and green on full, it gives me a bit too bright a color. So let me run that one. You can see what I mean. Control V, Control R. And that's where physical computing is a little bit different from theoretical computing, in that sometimes you have to play around with things. They match. I found that looked a little bit too green. All right, so we've got our colors. Now a traffic light, we know that a traffic light cycles. It goes through various cycles. So we need a control structure that goes around this red, green, yellow to cycle it through the various colors. So at the line number 5, where red is, I'm just going to move the code down 1 by pressing enter, going to the beginning of that line and pressing enter to move it down. And then put my cursor on line 5 where that blank line is. If I go to menu, built-ins, number 4, and I go to, I believe it's 2 for control. I have a whole bunch of different structures here. I've got conditional statements, I've got for loops, I've got while loops. So I'm going to use for index in range size, which is number 4 there. So I'll select number 4, and it says for index in range size. I need to select an index. I could just use X for my index. In range, and this is where the size of the number of times you're going to run through the loop would be set. So if I'm just testing this out, I don't want to put 400. Otherwise, the code will run for a long time before I'm able to go back and edit it again. So I'll just run it twice. And you'll notice below it, it's got this block that's tabbed in. So all I'm going to do here is I'm going to scroll my cursor down to where the red is and backspace twice or 3 times. And again, going down to the beginning of the green, backspace and enter. Going down to the beginning of yellow, delete and enter. And now my red, green, and yellow are all tabbed appropriately. Change my timing. The yellow doesn't stay on as long as my red and green does usually at a traffic light. And now I can run this code. Control R. And my code should run through 2 cycles of the red, green, and yellow. Green for 4 seconds, yellow for 1 second, flipping quickly back to the red, then the green, then the yellow back quickly, and then we go back off. And now you have made a traffic light. So some extensions to that activity that we've used in the past are trying to get like an advanced green. How would you do an advanced green? How would you do like a flashing yield sign, a flashing yellow or a flashing red? Another extension would be maybe making a crosswalk where you have a beep that happens as people try to cross the street. So integrating some of the sound with the lights. And as I said earlier, if you scroll back to the hub features on page 1.1, you can get an idea of where to start with some of that by looking at the code in 1.1 for the hub features. Another way to look, another place to look is in the menu. If you look at menu, and if you go to TI Hub, you get an idea of some of the things that you can do with the hub, with the built-in hub devices. You get your sound output as well.
Chris, quick question. So the Ontario Grade 7-8 math curriculum has coding in it. And how does this activity connect to that?
That's a good question. So let me transition back to the website. So if you're looking for connections to the Grade 7-8 math curriculum, I'll take you back to the traffic light website, the stemsupports.ca website. We've mapped a bunch of the curriculum expectations for grade 7 for this activity right here at the bottom. So that gives you all the direct curriculum connections for grade 7 there.
So there was a comment there's an interesting comment from Brad, I think, that ties to the curriculum connections. He said, I really like the sub-programs, nice way to make it streamlined. So is that sub-program just something nice that you did, or does it?
No, that's actually in the curriculum. If you look at expectation 3.1, it talks about a sub-program and other control structures. The sub-program here is defining a count and or a sub-program and other control structures, such as the for loop. So both of those activities, or both of those items in this activity address those curriculum expectations directly.
So the sub-program is when we built that little kind of function for red, and then you reference that function in that other program page. Is that the,
That's
okay.
right. And if you're new to coding, I find that looking at page 2.1, if I transition back to that, if I look at page 2.1, for X in range 2, red, green, yellow, is a lot easier to understand and less intimidating for a new user than looking at this page with a call to those colors or all the different colors and numbers and codes in there. So I just find it's a lot less intimidating to have those sub-programs in a separate tab, and just looking at this page saying, this is where we're going to write our code to run the traffic light.
And I kind of, the other thing I liked was when you're running the code, the little text prompts that go along with, you know, oh, now the green light's on for 4 seconds.
Right. You know,
that's kind of a nice touch too. Yeah. Yeah.
All right, well, at this point, we're at 8 o'clock, and if anyone has any questions, they're welcome to, happy to entertain them.
Okay. Can you do me a favor, Chris?
Yeah.
Can you run just do a random integer from 1 to 8, please?
Sure.
And you can stop the recording now if you'd like to. Thanks.
Sure. get back to that too. Recording.
And then just as Chris is kind of doing this,